Yeah, so so based on where we stopped last time, I'm gonna continue from there. And I think I explained all this to you and what they do. Right now, for this particular server side, we have the dependencies and the dev dependencies. The dev dependencies are what actually run locally. Why this when deployed to the internet, this will get executed. So they are about they are meant to run both locally and online. Why this is meant to run locally. So let's start from the let's look at this some of these folders here. So I have this HTTP folder, the middleware folder, the model folder, the node models folder, the routes folder, the service folder, the util folder, the .env file, the .gitignore file, the .sql file, the app.js file, the example.eml file, the package.json file, and the package.json file, then the readme.md file, and the tags.md file. The HTTP file here contains some of the base HTTP requests which you need to make for when testing this out. So this one you don't need to make use of it. This is just for testing purposes. While the middleware folder, I'll come to this. I'll come to this later. Then the model folder simply contains our database configuration. Right now, the database in which we are making use of is called PostgreSQL, and for we to configure node modules to configure Node.js to work with PostgreSQL, we need to add some configuration, the PostgreSQL config file here, and we're making use of a library called Node Postgres to work with PostgreSQL from our Node.js file. And these are just this basic configuration. We have the host name, the user, the database, the password. I don't know if you get this. So this all is like right now you are looking at this. You saw process.env that's the database host, process.env the database user. If you ask where are all this stuff coming from, well, they're basically coming from the .env file. The .env file enables us to store secret information where we don't want to expose to the server side when this particular stuff is being deployed. And for it to access an environmental variables for full name, why .env for short name. This env simply means environmental variables, and they actually way to store some information which you don't want to expose to the main user when this particular stuff is being deployed. So for me to make use of this particular library, .env library here, which is you saw here, enables us to work with environmental variables within our Node.js project here. So for we to access .env files, we need to configure it. And for we to configure it, we require the .env module. After requiring it, we call the .config method from this particular class instance. Then as we need to make sure this is always at the top each time we want to make use of a environmental variables in our file. So for you to access each environmental variables, just as you saw here, we have the database host, the database user, the password, the database name, then the JWT refresh token, and JWT access secret. Sorry, not token. So for you to access this, we make use of the process. The process is actually an inbuilt package within the Node.js. So the process has so many methods here, and one of those methods is called .env, which actually give us access to environmental variables. I'm going to show you a bit what this stuff does. So let me just open Coca. So let's look at what this process contain. Sorry, the .env method here contain. So we can simply log this out. Let me close this terminal down. We can simply log out process.env. Now, as you can see here, these are so many data here. We have the all user profile, the app data, the application inside. The process.env contains both your system environmental variables and the Node.js environmental variables. Like now, the ones which we've set are called database host, database name, DB password, and DB user here. So this is what we've set up already, and the only way we can access it, as you can see here, the .env file, the .env method is return. This particular method here returns an object having both a key and a value here. And for we to access each of these environmental variables, we need to reference the key. And the key name is actually this what we have here, database host. Then once we reference the key, we'll be able to get the value. And that's the reason why we are calling it like this. Process.env database host and database user, database name, and database password for short. So each time I click on this, you are seeing both the value, Postgres, Babcock, Uber, and the password, which is 1234. So this is really cool. So that's for that. Then let's move on to our middleware. I'll come to this later. Like I said, let's move on to our let's look at this git ignore file here. So as like I said before, the .git ignore files tells GitHub or tells the Git which particular tells GitHub what particular folders or files which should be ignored when you finally push this to your GitHub repository. So right now, if you go into the project repository, you won't be able to see this particular folder here called node modules. GitHub will definitely ignore this based on this particular file here. And the .sql file, this is just for placeholder. They don't actually do anything yet. So this is just for you to see what actually where we're actually storing the data from. So right now we make use of SQL queries called create database called Babcock Uber and create table and all this stuff here. So the table will actually be responsible for storing each of this data, both the ID, the name, the mail, the password, and other stuff within it. Then the table name is actually called users table. So this is actually how you write a query both in SQL and in other database like MySQL, PostgreSQL. Then for you to see what this query does is that you can simply copy out this. Then right now we have this database here, but you might ask where can we see where can we find all this stuff within our PC? So you can once you follow the instruction which I sent to you guys, I showed you how to set up your system to make sure PostgreSQL work on your system there. So the only way to do this is by going to your terminal. So if you're on Windows, you can simply type PSQL followed by dash uppercase U and the Postgres the user which was stored when you set up PostgreSQL. When you click on enter, it's going to ask you for this particular user here. So I'm going to enter the password for this user. The password I set for this user is called 1234. So right now it's connected as Postgres. This is actually the main database for this particular user. And within this user here, within this Postgres user here, I created a database called Babcock Uber. For we to see this particular database, we can simply connect to it by making use of /c. Then the database name called Babcock Uber. Right now we are connected, as you can see, it says you are connected to a database called Babcock Uber as Postgres user. So let's look at the tables here. So /d, this particular flag called /d helps us list all the tables within this database here. So as you can see here, we have the tables of users table and trips. For now, this particular project doesn't make use of trips, so it only makes use of the users table for now, not trips. Trips, the intention for me of creating trips was just to store each of the user trips. Each time the user picks up a write from the code here, so it stores the trips here. But for now, this particular table is empty for now. So the main table, which is this, is called users table. For me to see each of these data or the data type or the table info for this particular table here called users table, you can simply make use of the command called /d followed by the table name here, which is users table. Sorry, this /d users table. So we have to surround this by quotes if the user's table has a camel case notation. So right now this particular table contains each of these columns. The columns are ID, name, mail, password, user's identifier, profile pics, user roles, status, phone number, refresh token, and credit at. And each of these has a type of text. While this particular ID here, as you can see here, the ID is actually has a primary key and a unique constraint. Definitely, this means that each time a user register, there must surely be a unique data within this table. Two users can't have the same IDs, and also different users can have the same email. So this must surely be unique. That's the reason why this you are seeing here is called unique here. So the key here, sorry, this particular ID column has a primary key of ID, and the column name here, mail, has a unique constraint, which means that the mail must have, every time the user registered, the mail which the user puts in must surely be unique. Two different users can't have the same email address. That's what this particular stuff means. So if you want to see what data which are actually in these columns here, you can simply make use of the SQL query called select all from, followed by the table name called users table. So it brings out all this data. Right now you are seeing this is actually not really formatted well. That's because it's actually in the terminal. But as you can see, it says ID. This is the ID here, the name here, the mail here, the password. This is the hash here for that particular user password, and so on. Then that's all for this. These are what SQL queries does. So let's move on to the app.js. So the app.js, before I move on back, let's go to this package log.json. The package log.json and the package.json contain useful information about this particular project here. So that's what you need to know about that. While the readme.md file contains what's the information which is going to be showed up when we finally deploy this to GitHub. So let me just show you guys what this actually is. My internet has a problem. /Babcock APIs. So this MD file, this extension called MD, that actually means Markdown. So it enables us to write some Markdown syntax, which will definitely be converted into an HTML template style. So you have this here. This information you are seeing here is actually what you are seeing in this particular Markdown file here. So you don't need to bother about that. Then let's start from the beginning. Now app.js. The app.js actually is the root to our it is like the entry point to our application here. So the app.js contains different files and different logic for this particular application here. So firstly, what you're seeing is actually called modus in Node.js. So the way we can create modus is by requiring it. All this stuff you're seeing here, Express.js, body parser, calls, efforts, paths, HTTP, socket, they're actually modus in Node.js here. So they are packages which is being created using Node.js and other stuff. So for me to make use of the Express.js, so right now this particular this project here is being built upon Express.js, and Express.js is actually a Node.js framework which allows us to make write API easily. So let's look at expressjs.org and see what they have for us here. Don't think this is the URL. Come. So as you can see here, it says express, fast, on not opinionated, minimalist web framework for Node.js. So it's basically a simple framework for Node.js. Everything, instead of you writing the hardcore logic of your Node.js application using the default Node.js, you can simply make use of this particular package called Express to make things much more easier for you. As you can see, it says Express is a minimal and flexible Node.js web application framework that provides a robust set of features for web and mobile applications here. So that's what this particular stuff does. The why for this particular package called body parser, the body parser enables us send incoming data from our clients. So let's say you want to send in files or JSON data, you make this body parser makes that possible. While the cause package here enables us deal with cross origin resource sharing policy error. And what does that mean is that if actually your application this particular application built on open of React is serving on a different port, like now it says it's serving on port 3000, why this particular this particular project is serves on a different host called port 5000. Now these two ports are not the same, and when you are trying to make requests to a particular API or hosts which have different hosting or ports, the browser throw an error there, which decline the request. And the reason why is just for safety precaution, because sometimes some malicious code might want to take in information from a different server having different host name here. So the way to fix that within our Node.js is by making use of a package called calls. So the calls enables us to get rid of those error and allow us to make requests to and fro from both the server and the client. So let me just show you what that particular package is. So let's look at this. So this is the package here, calls. So the full meaning of this package is called cross origin resource sharing. So as you can see here, it says calls is a Node.js package for providing connect/express middleware that can be used to enable calls with various options. Let's look at this. Let's look at what Wikipedia has for us here. So as you can see, it says cross origin resource sharing is a mechanism that allows restricted resources on a web page to be requested from another domain outside the domain from which the first resources were served. So definitely all this what is saying is that, let me just give you an example. So you have your client here. Let's say this is your client here. This is your client is trying to make requests to your server here. This is the server here. This is server, and these two this particular two third parties have different domain name, like port 3000. So serving on port 3000. Why this is serving on, let me write this way, sorry, serving on port 5000. So when this particular client make requests to a resources which has different domain name outside from where this particular resources was called, the browser cancel that request. So it once it's cancelled the request, it shows an error within the browser. So which means we can actually get data to and fro from this server when this particular stuff is enabled from the browser. So the only way to go around this is by making use of a package called calls, like I've showed you guys. So the package actually does something under the hood which goes on within the browser itself, allowing us make requests to and fro from both the server and the clients. So let's move on. Why the FS module? The FS simply means files system. It enables us to work with files within our Node.js. Why the path modules here also enables us to work with different paths. It enables us to traverse different paths in our application here. And the HTTP module enables us to create a Node.js server which is being declared in this particular project here. While the socket.io is responsible for creating a WebSocket server here, a WebSocket server instance within our application here. So as you can see here, it says, I'll go over this right now. Then let's move on this. So the only way to make use of Express.js is by making use of the Express instance, and we assign the Express instance to a variable called app here. So the app actually contains the Express instance here. So we now, for which create a server in Node.js, we make use of the http.create server method here, which has access to the Express instance here. The Express instance also makes use of this HTTP server behind the scene. So HTTP module behind the scene. Now make use of IO here. The IO is simply a socket.io feature which enables us communicate in real time from both the client and the server. So this is actually the configuration for making use of socket.io library here. So this function here enables us handle socket connections, while these are just the Express.js middleware. So I will leave all these links below. Let me just create a new file called links.txt. So I'm going to leave some links for you guys to go through. Look at this first. Let's look at Express.js. Then we have socket.io. So this particular library called socket.io makes use of WebSocket behind the scenes to make real-time bidirectional communication from both the client and the server. So the reason why this is more preferable over HTTP is that when you make requests using some HTTP method like get, post, put, patch, and delete request, once the request reaches the server, it might take some time for the server to get that particular request and do some necessary logic. So socket.io makes it more possible. Like it removes the waiting from both this server and the client. So once you make a particular socket, once you emit a particular socket event, this particular socket event doesn't make use of any WebSocket, doesn't make use of any HTTP method behind the scene. It makes use of WebSocket, which allows you to make bidirectional communication between the server and the client here. So as you can see here, it says bidirectional and low latency communication for every platform here. So it says in most cases the connection will be established with WebSocket, providing a low overhead communication channel between the server and the client. It says reliable, rest assured. In case the WebSocket connection is not possible, it will fail back to HTTP long polling, and if the connection is lost, the client will automatically try to reconnect. And it also shows some components which makes use of socket.io library. So all these are some components making use of it. Let's move on overhead. So let's move on to the so all these are the configuration meant for Express.js middlewares. So for we to make use of a particular route, so let's look at routing. What does routing mean? So routing enables us to access data from a specific endpoint. So let's go on to google.com. So I move to google.com, it shows this page, but how come? How is this possible? So when we type in google.com is actually a particular route in the browser. So when we make use of this particular URL, when we type in this URL wu/google.com, it makes requests to the server. It makes request. The browser makes request to a server within the Google engine. So once you make request to this server, that particular server within the Google engine has a route handler which checks if actually a route is being made to either slash or slash whatever. So once a particular route is being made to that particular route handler, the server sends the request, and the request can be in any format. It can be in a JSON format, it can be in an XML format, and it could also be in an HTML format here. So it makes use of that particular route. Once you send the request, it sends the request, then the server sends the response. The response can be an HTML, JSON, or XML. And once the response reaches the browser then pre-rendered that particular response, which we are actually seeing here. So the way to actually apply this logic in our application is by making use of an express route handler. The express route handler enables us to have get a particular route parameter or routes, then configure that, then handle the routes based on the logic here. So right now, the browser, well, when you make requests from the browser URL, it makes requests to the server using an HTTP method called get. The get HTTP method allows us to get some data from the server. So I'm going to show you what this HTTP method was. HTTP methods. So like I said, it says the primary or most commonly used HTTP methods are post, get, put, patch, and delete. These methods correspond to create, read, and update and delete functionality operation respectively. There are a number of other methods too, but I don't think this is actually defining what we are looking for. So let's look at some other stuff. So right now it says, now let's look at what the get request. When the get method request, the get method requests a representation of the specified resources. Requests using get should only retrieve data. So when you're trying to retrieve a specific data from the server, a get request is being used. While for post here, the post method submits an entity to a specified resource, often causing a change in state or side effect on the server. So when you're trying to transmit data from the client to the server, an HTTP method called post is being used. But when you're trying to update a data from the server or your database, an HTTP put request is being used from the client. As you can see, it says the put method replaces all current representation of the target resources with the request payload. So it's definitely replaces or updates. While the delete, as the name implies, as the method implies, it deletes a specified resources. And these are the other different methods which the browser makes use of, both the browser and the server. So now let's look at what this stuff does. We are definitely making use of the Express.js app instance, followed by the get method. The get method is actually an HTTP method called that we've just seen below. So I'm going to go over. I'm going to leave the link for you guys to go through it. Let's look at this one. So what is wrong? What is this? The app.js. So the get method here simply tells the server if there is any request coming in from the root. The root is definitely defined as slash. So slash basically means the root of the server. Like for example, our server is being run on localhost port 5000. The root will definitely be the slash. So when a request is being made to this particular route here, you want to send them all this data here. You want to send this particular data, and the data is coming from the package of JSON here. So we are sending them this information here, and we are basically making use of the FS module here. The FS module here, which is the file system, enables us to work with files within our Node.js application here. So as you can see, it says fs.read file. The read file method here helps us to read a particular entire data from a specified file. The file here is basically making use of package.json, which you are seeing here. So we read this entire data from this file. After reading this data, we get this particular method throws a callback. The callback would actually get executed if all this stuff returns successful. So once this stuff runs successful, the callback get executed, and the callback takes in two parameters. It has both the error and the data. The error is actually would actually get filled up when there is an error in reading the file. So let's say this particular file doesn't exist, we're going to throw an error. So we're trying to check if actually that error exists within our server. So we check if there's an error there, we simply send the error to our client instead of making our server hang. Then else, if there is no error, we simply want to get the data. The data will definitely be in a string, and we can't send we can't transfer we don't want to transfer send string or text to our client here. We simply want to transfer a formatted data. So that's the reason why we convert the text to an object, making use of JSON.parse. So we are simply sending an object or a JSON data to our clients. So we simply push it into this particular array here. After pushing it, we simply send it back. We send both the response and the data. And as you can see, it says 200. So what does 200 means? 200 simply means an HTTP response code. So when you see 200 or 400 or 500, they're basically telling you an HTTP server response code. 200 simply means the server got the response correctly. So let me just show you what that means. Let's look at HTTP status codes. So I'm going to look at here. Let's look at this. So as you can see, it says, let's look at this, 200. So 200 simply means okay. It says the request has what succeeded. Why 400? Let's look at 400. 400 simply means what? Bad requests, or simply means code references. Why 500 is 400 simply means bad requests and code references here. So it says the server cannot or will not process the request due to something that is perceived to be a client error, e.g. malformed request syntax or invalid request message from framing or deceptive request routing. So this, and let's look at 500. 500 simply means what? Internal server error. So let's say the server encountered an unexpected condition that prevented it from fulfilling the request. So in this way, we are simply sending the request. So let me just show you what this does. So let's look at it. Let me just copy all this link and paste it here. 5 HTTP status codes. Then let's look at let's give an example. So let's say I want to visit a route in this website that doesn't exist. So instead of the browser showing a blank page, once we make requests, let's say to something that doesn't exist, this request will reach the server. The server checks if actually a request is actually present, or this particular route is actually present in the server. If this specific route isn't present, like slash whatever, if it isn't present, the server itself can simply send a different status code. Let's say a 404. A 404 status code means not found. So let's look at this. As you can see, it says what? Error 404, page not found here. So in this way, instead of allowing our browser or our site to display a blank page here, we can simply display an error code here. So let's watch this now. So let's say I want to display this a route that doesn't exist. It says here 404, the page we're looking for does not exist. So I've actually implemented this in your project. So each time the user tries to go into a specific route that doesn't exist within the server, or the client, we can simply throw them an error message here, which will make the page or the site much more flexible. So let's look at this. Let's go into localhost, then put 5000 like this. So right now, this is the data which we talked about here. We are simply getting the reading a particular file here, then displaying those data. This is what we are seeing. All this data is coming up from this particular file here. So there's no magic here going on. Then we are simply define our express routes handlers. All the stuff are express route handler. So what this does is that this app will use tell Express that it should make use of this particular middleware when sending a request here. Then we define our ports. We listen for an HTTP port to run and start the server. Then we simply say server will listen on this specific port here, 5000. Then the server we simply start the server just as you saw here when we run the server code here. Is it this? I'm not sure it's this. Sorry. As you can see, it says what starting our Node.js server here and all these stuff here. So this is what goes on behind the scene here. Now let's go into the main stuff of this project. First of all, I'm going to go into authentication. So for authentication here, let's look at how the server handles authentication here. So let's say you want the user to register. So you want the user to create an account from the client to the server. When the user fills in all necessary data, all this stuff here, when they send the request, how does the browser process? How does our server here process those requests? So we simply define a route here. So we simply make use of a router, the ExpressJS router here, router instance. So the router instance enables us to listen for a specific route within our project here. So we simply say when it's a request to an API/alt/register, we want to do all this necessary logic here. So we simply check if these are simply sends a data, if there is data present. If there isn't any data present, when user makes a request, we simply want to show them an error here. If there is data present, we want to make use of this logic here, which is number one. We want to check if actually the row coming in from this client is student. If the row coming in from the client is student, we want to make use of a method which is coming in from this particular auth service here. So the auth services here, this is the user auth. The user auth contains different logic of both the admin and the students, or let's say the admin or the staff and the students here. So we check for the students and the driver. Sorry, not staff but driver versus students here. So let's say if the row coming in from the client has a payload or has a field containing row, and the row has a value of students, we simply want to call this method here, which enables us to register the student. Else, if the role is actually driver, we want to register the driver. Else, if no role is defined, we want to throw an error to the client here, saying invalid role type provided. So let's look at this. So when let's say the user is trying to sign up, and the role is student, this particular method get executed. Let's look at what's going on behind the scene of this method here. So the method is what? Registers student. So we are simply destructuring all this from the data. So this is what we call object destructuring. the structure enables us to access data without using the dots followed by the key name. So we're simply getting all this data from this particular, we are destructuring this data from this variable here called data here. So after destructuring it, we are passing in our response object here, because we defined it up here. And once the data reach here, we do necessary we make use of necessary validation. We simply check if all this data is defined. If all this data are defined, we simply move on to the next step. If they are not defined, we throw an error to the word user saying input fields can't be empty. If the name is empty, or the email is empty, or the role is empty, or the phone number is empty, or the matrix number is empty, or the password is empty, or the name is empty, or is undefined, or the email is undefined, or on all this stuff doesn't exist within the payload coming from the client, we simply throw an error saying input fields can't be empty. Then else, if all this data are present, we move to the next step. The next step is this student identity. We simply create a student identity making use of their matric number. So as you recall in the last time, I said the matric number has this. It's coming in with 18/0032. So we simply get their matric number. We remove white space from the matric number. Then we split the matric number into an array containing two different items. First of all, the first item will definitely be 18, and the second item will definitely be 0032. So we are simply saying if the matrix number contains slash, what we want to do is that we want to append student followed by the matrix number here, and student followed by the matrix number here. So we are simply checking if the matrix number contains, if for example, let's say the user types in, or let's say the student types in 180032. We don't want to just store this like that. We want to validate it to check if actually, if slash doesn't exist in our matrix number, we simply want to split it by a space. We definitely split this into an array here. So we simply split this into this 1800032. We split it like this. When we split it, we simply converted it into a string. So before we do all this, we simply check if actually slash exists within the matrix number. If slash doesn't exist, we do this and convert it back to a string. Else, if slash exists, we simply split it by the slash, making it look like this: 18 then 0032, like this. So if the user types in slash here, we simply do all this. Whereas if no slash exists, we simply convert it to this 1800032. So we do all this stuff here. Then that's that for the student identity. Then we simply validate the matrix number. The validate matrix number is coming in from a file called util. The util file there has a method called validate matrix number. So this is the method here. I've discussed this later on. The first time we did all this, I told you guys what was going on behind the scene with this. So hope you know that. Then we validate this. So if the matrix number isn't correct, we definitely return what? False. If it's correct, we definitely return what? True here. So we are checking if the matrix number is simply valid. If it is valid, it returns true. If it isn't valid, it returns what? False. So we check if the matrix number is valid. If the matrix number isn't valid, we simply throw an error to the user saying what? Invalid was matrix number provided. So we throw an error to the user here. So then we also check, we validate the phone number and we validate the email too. Then Instead of us storing the user's information into the database directly, we don't want to just store their information directly. Instead, we want to check if the user has already registered before, because we don't want two different user having the same information as before. That will make our database prone to error. So we simply want to check, and we simply check using this SQL query called select all from users table, where the email address is equal to the email provided by the student, or the phone number is equal to the phone number provided by the student, or the student identity, or the user's identifier is equal to the student identity. So we check all this. If an error occur while doing all this, we simply throw an error to the user. Then we check. So how do we know if the user exists within the database table here? So within this parameter called results, the results has a key called row count. The row count returns from 0 to whatever number. So it can return 0, 1, 2, 3. So it returns 0 if that particular data doesn't exist, whereas it returns 1 if that data exists. So we are simply checking if the row count is greater than what? 0. If it is 1, we know that the row count is greater than 0. So definitely we know that what the user already exists, and we simply throw the user an error. Else, if the row count isn't 0, we insert the record using all these SQL queries here. So we simply make it insert into all this stuff. Insert into SQL queries followed by the data we want to insert into the database. If there is an error inserting those data, we simply will throw the error saying something went wrong. Else, if there isn't an error there, we simply throw if no error occurred, we simply throw a message saying the user successfully registered, and then we simply know that what the user has successfully registered. So let's see how our front end is able to communicate with the back end here. So how do we make this possible? Well, we can simply make this possible using an API. So what we just built is actually an API that allows the client to talk to the backend or to talk to the server. So how does an API works? An API simply sits as a what is this? I can't want you. An API simply sits as a middleman here between our client and our server. So let's say the client is trying to make requests to the server. Instead of this isn't possible like that, so we need to make an API. The API simply makes that possible. The client talks to the API here, then the API talks to the server, then the server itself talks to the API when sending data, and the API talks to the client, making it to and fro. So the API simply sits as a middleman from both the client and the server here. Hope you guys understand that. So let's look at how that is possible. So let's say I want to register a new student called Peter, and Peter has a phone number called 080 544 89449, and he has an email called peter@mail.com, and he has a match number called 18/42 and a password of 1234. This will surely execute successfully because this user isn't present in our database. But what if we want to put a user who is present in our database? For example, John is present in our database. Let's look at this. When we click on create accounts, I think I was wrong. John is actually present in our database here. But now let's try to register this same Peter as a student here. When we click on create account, it says what all fields are what required. Password is missing. 1 2 3 4. Create account. It says what all fields are required again. Which all fields are required? It's my this and that. I think something's wrong. Let's refresh the page. Peter 080 544 89449. Peter, let's say john@mail.com, and this we click on create account. It says what user with that email or phone number match number already exists, so we don't want to keep on inserting records into our database that is already present. So that's the reason why I did all those stuff here. So let's try to register a new driver. So we say let's say Brad 2Q, then phone number 060455. Email should be what brad@mail.com, then 18/ the Brad. Since it's a driver, we don't need to put in a matrix number because it requires a license plate number. So we can simply say BBB56 and password. Let's click on create account. It says invalid phone number. So let's look at this. Let's change our phone number because the phone number is wrong. It is 449 and click on what create account. It says license plate number is what invalid. AAA 550. So definitely this is invalid. Let's put in slash and click on what create account. It says account created successful. So that is how the register logic works of both driver and what student. So the login process, how does it works? The login process will work similar to the sign up process, only that the login process only requires your what matric number if you are a student, and what email or phone number if you are a driver. So you're meant to log in with your matric number if you are actually a student. If you are a driver, you are meant to log in with your what license plate number. So your phone number, no matric number, no license plate number. And let's look at this. We are simply accepting what we are verifying, or we are validating the request coming in from the client doing all this stuff. We are also checking if actually the matric number is present. If it's not present, we are throwing an error. And secondly, what do we do next? We destructure the data. We destructure all this stuff from this data here. Then we check if the user trying to sign in exists in our database, because if the user puts in a wrong request, a wrong data that is not present in our database, we know that that user hasn't signed up yet. So we simply check if the result is equal to what 0, and then if the user isn't present, we simply will throw an error saying user with that matric number doesn't exist. Then what do we do next? We simply check the password, because we don't want the user to type in a wrong password. So we simply get those data, we compare the hash. We are making use of a library called bcrypt.js to compare the user's password and the hash which is recorded in our database. So it simply takes in a password and a hash coming from what the database. So let's look at this. So this is the hash here. The field here contains a hash like this. So it simply checks if actually the string matches this hash in the database here. If it doesn't match the hash, we simply show a password, say password is what? Incorrect. If everything went well, we simply extract some data we want to save in our client, because this data would be used when authorizing the client to a specific page. Because we don't want a client to access a route that he or she doesn't belong to. We want to prevent them from accessing or reaching a route that is meant for a specific user. For example, we don't want the student to access the browser, the driver's route, or the driver's page. That will be insecure. So we simply send all this data, make use of a library called JWT. The JWT enables us to create a token, which we then, it enables us to sign a token. When we sign a token, instead of us storing a hardcore data in our clients, let's look at what JWT does. JWT.io here. I'm tired. So this is what we want to store in our clients, something, a token like this. So instead of us storing a hard coded data like the name or email or password, we don't want to do that because it will be insecure for our clients. We simply want to store a reference to those data using this token. So what this library does is that it generates a token. As it generates a token, so it signs a token. The token includes the algorithm which was used in signing the token, either #256 and the type. It also includes the verified signature, or who owns that particular token. Then it includes the data which is being stored within those tokens here. So we want to store this in our token, or we want to store all that data within what our token here. So that's the reason why we are doing all this. We are doing this. We simply want to store this in our. We simply want to store this within our token. And after storing this within our token, we update the refresh token, because by default the refresh token will be left null or an empty string. The refresh token only gets filled up only when the user signs in. So we update the refresh token, and once we update the refresh token, we simply send all this data within to the clients. So we send all this data within the clients. We simply store those data in our client, in our server, so in our clients there. So this data will be sent to our client, which is the browser, and it's being stored there. So let me show you something. So let's say we come in here, we sign in as 18/0032. So right now no data is here, and that's because what the user hasn't signed up. And we don't want to leave this place like this. We want to store those tokens or those data which was sent from the server to the client here, so that the browser can identify who and who should access a specific route based on the logic of our application. So when we click on sign in, it says what logged in successful. And then when we come back to our client, we simply see a particular key called Babcock auth. The Babcock auth contains the access token which was generated through JWT and the refresh token. To see what data is being stored in our access token, we can simply do what? Copy out the access token here. So let's look at this. Let's copy out some data which is it. So let's just copy out this access token or refresh token, or this token signed from our server, and let's see whose data is present within it. In this way, we are not storing a malicious code within the browser, because if we store the user password, we need this token, it will be insecure, and users can simply come into this browser here and copy this token, go into JWT, paste the token here, And what you see, we see the mail of the user who signs up, the role, the status, and the students here. So the status will definitely be off for students, but why for driver it's going to be what, on, because the driver will definitely be on. And you also see the user ID coming in from the what, server here. So I don't know, I'm not sure if your lecturer will be able to ask you all this, because um, he won't be familiar with all this. I think he will ask you question lesser than this, not all this, because it takes time for you to understand all this. So I'll definitely leave a link to that for you guys to go through on your own. Then the same method applies when logging in the drivers. So that's all for authentication slash authorization. I'm going to come again. Authentication deals with let's look at what the browser, let's look at what Google says. What is differences between authentication and authorization? It says, simply put, authentication is the process of verifying who someone is, whereas authorization is the process of verifying what specific applications, files, or data users has access to. So what we've just did, we've just done the authentication as well as authorization, because right now the user can't go into the driver's page, because why? This particular user is actually a student, and for you to go into the driver's route, you need to have access to some data which the driver have access to. So we've prevented some things which definitely show up here for in both the driver and the user here. So I hope that explains it all. Then let's move into this. I'll be coming into this later on. Any